Welcome to part 2 of Points, Lines, and Planes. This is once again Mr. Vandermaiden. Let's start off this lesson with a simple definition. We've talked about points, lines, planes, and now really quickly let me just briefly introduce space. No, not outer space, but space. 3 dimensions. Space is the set of all points in those 3 dimensions, and we usually represent a space with a prism. Here you see a prism with vertices A, B, C, D, E, F, G, and H. And although we have only labeled the vertices as points, there are an infinite number of points throughout that prism, that space. Keep this in mind. It's going to come up again in part 3. Keep in mind that as lines have an infinite number of points on them, planes have an infinite number of lines on them, space has an infinite number of planes in it. Okay, let's move on now with some defined terms. Now that we have defined points and lines, we can move on to pieces of lines. So the first one that we're going to talk about is a segment, sometimes called a line segment. This is very simply part of a line with 2 endpoints and all of the points in between. We represent it with a straight path without arrows, so no arrows this time. So you can see in our figure now that we have segment AC, and we name it using the endpoints A and C in any order, and put the segment symbol over the letters. Notice the segment symbol there. It has no arrows on it. In our figure, we also have segment BC and segment BA. Once again, notice the order of the points doesn't matter. So now that we know what a segment is, let's talk about a ray. A ray is often referred to as half a line because it has one endpoint and goes off in one direction forever without end. So as you can see, it is basically half of a line. It's represented by a straight path that contains one endpoint and an arrow on the other end. So you can see our figure there. One endpoint at A, and the arrow goes off in the direction of B and C. We name it using the endpoint first, followed by any other point on the ray, with the ray symbol above it. So we have named this ray, ray AC. Notice that the ray symbol always goes to the right. We could also name this ray, ray AB. But now here's something to be careful of. The endpoint must go first. Notice the ray BA starts at a different endpoint and goes off in the other direction. Notice the symbol over the name, ray BA, still points to the right. In this figure, we also have the ray CA, which we could also name ray CB. But once again, be careful. Ray CB should not get mixed up with ray BC. Completely different endpoint, completely different direction. So in our figure, we actually have 4 rays. The final concept that we're going to be talking about in part 2 is opposite rays. Opposite rays are 2 rays with a common endpoint that form a complete line. It's represented by a line with 3 points on it. And of course, we'll use the normal naming conventions that we use for rays. So in our figure here, ray BA and ray BC are opposite rays. Notice that even though they go in opposite directions, the ray symbol in their names both go to the right. Okay, let's try it. Name all of the segments on line Q. Hopefully you can see those. There is the one that's closest to the left, segment GK, and there's segment KL, and then there's the segment from G to L, segment GL. Simple enough? Okay, next question. What are the names of the rays on line Q? The first ones we can think of starting at G. If they start at G, then from G to K, so ray GK, which can also be called ray GL. Then if we look at the other end, at point L, then we can say ray LK or ray LG. They are the same ray. And then if we look at the middle, ray KG and ray KL are the third and fourth rays in the figure. Finally, third question. Which of the rays in question 2 are opposite rays? Keep in mind they have to have the same endpoint and go in opposite directions, hence opposite rays. So the only two that have the common endpoint are ray KG and ray KL. Those are the opposite rays. Okay, really quickly, press pause, do this one on your own, and when you think you have the answer, come back and see if you're correct. All right, did you do well? Although ray GK and ray KG are going in opposite directions, they don't share a common endpoint, so they cannot be opposite rays. How did you do?